All right, this is one of the last sections that we're going to do. It is probability distributions and expected value. Those are the only two things that we're going to do. It is really straightforward. I know learning on the week before finals is kind of annoying, but it's really straightforward. So here we go. First, let's talk about what probability is. It is the measure of the likelihood of something that happens randomly or by chance. So like when, people get pregnant, the probability that they have a boy is 50% and a girl is 50%, right? Like that's the probability that that's going to happen. And then a probability distribution are these two. Either a table, this is the table, or a graph. So these are the two representations of a probability distribution. That shows all the possible outcomes of a probability experiment along with respective probabilities. And so in your situation, you will be given this and you will just be asked questions about it. Really quick, just about probabilities. It can be written, probability is the P of X, the probability of X, whatever X is. We'll give context to it later. The probability needs to be between 0 and 1, and it is written as a fraction or a decimal. These are all decimals, and you can convert these into percentages. So like this one's 10%, 15, 35, and 40%. They're always between 0 and 1. If it is 0, that means, oops, that's not the one I wanted. It will never happen. The event will never happen. And then a probability of 1 means it will always happen. If it's close to 1, it means it's pretty likely, like 0.9. You've got a 90% chance of that happening. That's pretty likely. And then if it's close to 0, it means it's not likely to happen. You've got a 1% chance this is going to happen. That's not a lot, right? And so that's kind of the gist of probability in a nutshell. Now, what are we going to do with that? So let's get some context to this. So this would be essentially, the X and the P of X. Okay, so, that rule should have been up there. And then the sum of all the probabilities for each outcome in the sample space is 1. I'll talk about that. Here's our example. In a bag of peanut M&Ms, milk chocolate candies, the colors of the candies can be brown, yellow, red, blue, orange, or green, right? All of these. And then suppose that a candy is randomly selected from the bag. The table shows each color and the probability of drawing that color. So like, essentially you have a 12% chance of getting a brown, 15% chance of yellow, right? So on, so on, so on. Or as a decimal, 0.12, 0.15, so on, so on. Excuse me. Here's one of the things that you will be doing, one of the two things in this lesson. Verify this is a probability model. Here's the two things that you need to verify that it's a probability model. This means the sum. The sum of P of X needs to equal 1, and P of X needs to be between 0 and 1. Those are the two rules in order to verify that it's a probability model. So P of X is the probability column. This just means the sum, aka they add up to be 1. So these probabilities, whatever you're given, needs to add up to be 1. So if I added up all of these, 0.12, 0.15, right? So on, so on, so on. Go ahead and do it in your calculator and pause the video if you need to. It will add up to 1. That means it's a probability model. Well, that's the first step. If it adds up to 1.01 or 0.94, even though it's close, it doesn't add up to 1. It needs to add up to 1 exactly. So first step is check. And then the second step is all the probabilities need to be between 0 and 1, aka no negatives and nothing bigger than 1, which that's all the case. This is between 0 and 1, this is between 0 and 1, so on and so on. So basically nothing bigger than 1 and no negatives. Oops, didn't mean to do that. So that checks too. So this is a probability model. To verify, we just need to check those two things. Let's say we know that it's a probability distribution. We know it's going to equal 1, but we don't know one value. And I don't know the context of this. Like, X is whatever you're talking about. In the last example, X was M&Ms. Maybe this X is how many goals someone is expected to make at a soccer game or something. So you've got a 12% chance of making 2 goals, a 35% chance of making 4 goals. Honestly, I just made that up, and it doesn't really make that much sense because in soccer you don't score that much, but just bear with me. And so we know that in order for it to be a probability model, all of these should add up to be 1. So I need to find this missing value, and I'm going to call this missing value X. And what we can do is if we are just going to find one missing value, let's add these up, the ones that we know. So if I added up 0.12, 0.35, and 0.24, I would get 0.71. And that 0.71 plus that missing value all together should add up to be 1 if it's a probability model. And then we can just solve for X by moving that 0.71 to the other side, and I'll get 0.29 for that missing spot. And that would be your answer. So that's probability models. They need to add up to 1, and they need to be between 0 and 1. The last thing that we're going to do is expected value. All right, so when considering all of the possible outcomes for an event, we can compute an overall or average value for the variable. This is called the expected value, and is calculated, well, this is the official, whatever you want to call it, rule. So basically this is saying you're going to take this and multiply it by the probability. Plus, you're going to take this and multiply it by the probability. Plus, you're going to take this. So this is what that says. But I really just take this table and I circle the two that go together, and then I put a plus sign. Circle, plus, circle, plus, circle. This tells me that I'm going to multiply these and then add. Multiply, add, multiply, add. So let's go ahead and do that. And that's all you do when you want to find the expected value is you're finding the average. So let's just, let's give some context to this. Let's say this is how many Netflix movies people watch per month or week, I don't know. So you've got so let's say 21% of people watch 2 videos a month, and 45% of people watch 3. 14 watch 4, and 20% watch 5, all right? And we want to say on average, right? What is the expected value? On average, how much do people watch? And in order to do that, we need to multiply. So if I multiply 2 times 0.21, and I would go ahead and do this in your calculator if you can, I get 0.42. And 3 times 0.45, I get 1.35. It's okay if you get values bigger than 1 here. And if that doesn't make sense, I'll explain it when we get our answer. So I did that for each of them. I multiplied and found my answer. And after you multiply, you want to add them all together. So we're adding all of these values. And once we add all of those values, we get 3.33. And that tells us an average for whatever this is. So saying it's how many movies you watch on Netflix per month. On average, it says people watch about 3. A little more than 3 a month. 3.33 to be exact. And so it's just another way, like, I don't know if you remember finding average, if you actually had values, you added them all up and divided by however many there were. This is a little different when it gives it to you with a probability model. And let's do one more that looks a little different. So this is your x, as you can see, and this is your probability. And so if you want, I'll make a table. It's what we're used to. Ooh, that was not very good. There we go. And show you kind of how we get these. So our x values are 1 through 5. So we've got 1, 2, 3, 4, 5. And then the probability is what goes with it. So 1 goes all the way up to about right here. So I'm going to say that's 0.25. It's between 0.2 and 0.3. And then 2 is at about 0.1. You can estimate. It's not perfect. I try not to make it weird numbers. 3 is about 0.2. And 4 is about 0.05. And 5 is at about 0.4. And if it asked you to verify that this was a probability model, you just want to make sure that these add up to 1, which they do. If you want to do that in your calculator. Oops, I'm sorry. And they are all between 0 and 1. But we are asked to find the expected value, which is what we just did. Oops, didn't mean to do that. I'm sorry. There we go. Trying to change colors here. So if you want to pause and try to do this on your own, go for it. If not, I'm going to keep going. It's the same thing. I just made it look the same from this graph. And here we go. Multiply, add, multiply, add, multiply, add, multiply, add, multiply. And so when we multiply these, that's what I get. Multiply these, I get 0.2. Multiply these, I get 0.6. Multiply these, I get 0.2. Multiply these, I get 2. When I add all these up, I get 3.25. So whatever it is that we were talking about here, the average is 3.25. So, like I said, it's not too bad. These are the two main things you'll be asked. You'll be asked, if anything, about these on your final or homework, what the expected value is, or if it's a probability model or not.